Hi, I'm James with renergycafe.com, and thanks for checking out our lecture series on electronic principles. Right now we're working on parallel circuits. We just finished covering series circuits. I'm going to go ahead and draw one of those series circuits for you right here. This is your simple series circuit where you have your small end here on your battery, a negative, big end, positive. And we'll go ahead and make this 12 volts DC, which is what we're working with in the series circuit. Okay, so this is your typical series circuit. Now, a parallel circuit is just a little bit different, but it behaves entirely different. This is what a parallel series circuit looks like. A parallel circuit looks like. Now, let's go ahead and throw a couple resistors in there and work this out. Now, things are going to operate a little bit differently. We know that voltage is measured across 2 points. And the difference between a series and a parallel circuit is that a parallel circuit, the voltage is the same at each point. Considering that if we're measuring over this resistor right here, obviously we're measuring the same voltage at 12 volts here as we are here, as we are here. We're going to go ahead and call this R1, R2, and R3. The voltage is going to be the same across all of these. That's fundamental to understand. Now let's go ahead and give these some values. Let's say that this is 2 ohms, this is 3 ohms, and this is 4 ohms. And let's go ahead, plug them into our formula, and we'll go ahead and work this out. E equals I times R. So we'll take E equals I times R. E in this case is 12 volts. And we know that's going to be pretty consistent. 12 volts. And we don't know our current. We're going to have to figure out what our current is, because our current is going to be different across each of these points, seeing as we know that we have the values for the voltage and the resistance across all these points. So the only thing we don't know is the current. So if you want to figure that out, let's take the 12 volts and let's go with 2 ohms. Let's figure out what the voltage is, or what the current is across here. 12 volts, I, and the resistance is 2. Now what we have to do here is divide both sides by 2. And what we end up with is I equals 6, so we have 6 amps. So we already know that we have 2 ohms and we have 12 volts. But now we just figured out that we also have 6 amps. (12 volts, 6 amps, 2 ohms. Let's move on to the next one. And let's go ahead and go all the way out here to R3. And what we want to figure out is across this point right here, knowing that the voltage is 12. Put our formula up there. 12 volts equals I times 4 ohms. So let's go ahead and divide both sides by 4 so we can get the I by itself. And we end up with 3 equals I. So we have 3 amps. So we know that we have 3 amps, 12 volts, and it's pretty simple. It's pretty simple to work that out. And again, if you don't have everything, say you just happen to know, for the sake of it, what the amperage was coming across here, you could just plug it in the formula and work it how you wanted to work it to figure out what it is that you're looking for. So the important thing to remember here is that in a parallel circuit, you're going to have the voltage remaining the same across all points. And in a series circuit, you're going to have the current remaining the same across the whole point. So that's the difference between series and parallel circuits and how to work them out. Obviously it gets a little bit more in depth than that, but this is the basic understanding. So if you see some videos and they're talking about series and parallel circuits, or in some of the future explanations of, for instance, electrolysis, that get pretty in depth, you'll understand the difference between a series and parallel circuit and how to set those up.